let us see the names of the 6 chapters: reflection of light at curved surfaces, chemical equations, acids, bases and salts, refraction of light at curved surfaces, human and colorful world, structure of atom. As these seems to be very easy chapters, and here reflection of light, this deals with the mirrors, and the refraction of light deals with the lenses. Chemical equations is a very small chapter. Acids, bases and salts, very enjoyable chapter. Human and colorful world, that is the chapter where we are using in our daily life, and somewhat different chapters, structure of atom. Of course, now let us revise all these chapters. So while revising, now I am comparatively revising the chapter 1 and chapter 4, because this is the reflection of light and refraction of light at curved surfaces. These two includes the same components, but the diagrams will be different. That's why I am comparatively discussing these two chapters. Next. Now let us see. If you see the first chapter, these are the main concepts what we are discussing: curved surface, concave and convex surfaces, points on the mirror, pole, focus, center of curvature, distances that we measure in the mirror, focal length, radius of curvature, object distance, image distance, and how to draw the ray diagrams, and the characteristics of images formed, and experiments, focal length, finding the focal length, and verifying the characteristics of images formed, mirror formula, magnification and uses. These are the main points what we have to discuss in the first chapter, and the same will be in the fourth chapter also. Now let us discuss one by one. Now, reflection indicates it is the process in the mirror. Refraction is a process in the lens. Now, in the curved mirrors we have two types: concave and convex. Concave mirror or convex mirror, whatever the mirror it may be, but the mirrors are manufactured by cutting a hollow sphere. So, a part of hollow sphere, glass hollow sphere is cut, and the outer part is colored, and the inner part is the reflecting surface. This is called concave surface or concave mirror. If the outer part is the reflecting surface, then it is called convex mirror. In case of lenses, this is the biconvex lens. This is the notation which we use for drawing the diagrams, and this is the concave lens. Right. Now, let us see what are the points we have to remember in the mirror or lens. This is the point P. This is called pole, and the same thing in the lens also. This F is the focus, C is the center of curvature. Center of curvature means we already discussed that this mirror is taken from a hollow sphere. So the C is the center of the sphere. The same thing happens here also. C1 and C2. These are the center of curvatures. Okay, next. And another distances. What are the distances in mirror? What we measure the distances? First, from pole to F, the distance is known as focal length F. In the same way, pole to center of curvature, the distance is known as R, that is the radius of curvature. Here also the same thing. From pole to focus, that is the focal length, and pole to center of curvature, that is the radius of curvature. Next. Now, this is the object. This is the object. From pole to the object, the distance from pole to the object is known as object distance denoted by U. The same thing here also. This is the object. From pole to the object, the distance is known as object distance, that is U. And here the image is formed. This is the image, and here this is the image. Now, from pole to the image, the distance between the pole and the image is known as the image distance V. In the same way, from pole to the image, the distance is known as the image distance V. Now, the most important thing in this is to draw the ray diagrams. This is the most important, and you will be asked so many questions based on the ray diagrams. So, you need not confuse about drawing the ray diagrams, because drawing ray diagrams is a very, very easy process. You have to understand some rules. Let us see what are the rules governed in the drawing of ray diagrams. First, come to the mirror or lens, whatever it may be. The first rule is any ray passing parallel to principal axis after reflection in the mirror or refraction in the lens, it passes through the focus. This is the most important thing. Now this is the ray parallel to the principal axis. After reflection it is passing through the focus. And here also this is the ray passing parallel to the principal axis, and after refraction it passes through the focus. This is the most important ray to be observed. This is the first rule. Next, come to the second rule. This is the converse of the first rule. Now this is the ray passing through focus. This is the incident ray passing through focus. After reflection it passes parallel to the principal axis. Here also same thing. This is the focus. This is a ray coming from the object and incidenting on the lens through F. Or like this also you can draw. Now after refraction it passes parallel to the principal axis. The same thing. This is the another rule. Coming to the third rule. Here the ray is passing through the center of curvature. So when the ray is passing through center of curvature and incidents on the mirror, after reflection it takes the same path backward. Here also the same thing. This is the ray coming through the center of curvature and incidenting on the lens. After refraction it passes undeviated. This is the third rule. Now come to the fourth rule. And this is the ray passing on the principal axis. After reflection it takes the same path backward. Here also same thing. The ray passing through the principal axis, after refraction it passes undeviated. These are the four rules which we use to draw the ray diagrams. Very, very important. If you remember these rules, then drawing the ray diagrams is very, very easy. So here we shall discuss how to draw the ray diagrams and the characteristics of images simultaneously. First, where the image is found, we have to understand the formation of image. So the image is formed where the two reflected rays are joined or two refracted rays are joined. That is the place where the image is formed. Now let us see, here the object is at infinity. See, so many rays are coming from the object, but we are observing only the parallel rays which are parallel to the principal axis. So all the parallel rays after reflection they meet at F. Here also all the parallel rays after refraction meet at F. Now the image is formed at F. So when the object is at infinite distance, image is formed at focus, and the characteristics of image. The image is real, point size. So it's very, very, very small size. So we cannot say whether it is inverted or erected image. Next. Now from the infinite distance, the object is brought to the nearer to the sea, that is beyond sea. Now here you see. One ray parallel to principal axis, after reflection it passes through F. Another ray passing through F, after reflection passes through the principal parallel to the principal axis. Now these two rays are meeting here. Now here the image is formed. This is the image. Now where the image is formed? In between C and F. In between C and F. Here also the same thing. Here the image ray is passing parallel to the principal axis. After refraction it passes through F, and this is the ray passing through the pole and it passes undeviated. Here the image is formed. Now observe the characteristics. The image is inverted. Here also inverted, and the size of the image is small compared to the object, and it is a real image. So these are the characteristics of it. So when the object is beyond C, you can obtain the diminished real and inverted image. Next. Now the image object is at C. Here also the object is at C. Now there the image is formed. Here the image is formed at C only. Here also the image is formed at C only. It is inverted. That is also inverted. Now, but what is the size? When object is at C, image is formed at C, and the image is real, inverted, and same size of the object. This is another characteristic. Next, when the object is between C and F. This is the most important. This is C and this is F. Now the object is at C and F. Now the image is formed beyond C. Here also the image is formed beyond C. Now observe the size of the image. The size of image is enlarged. So when the object is between C and F, the image will form beyond C, and the image is real, inverted, and enlarged in both the cases, with mirror and lenses. Now the object is at F. Here also object is at F. Now in the diagram it seems to be that the lights are not, the reflected rays are not intersecting, but they may intersect at a very large distance, so the image is formed at infinite distance. So as the image is formed at infinite distance, it is real, inverted and enlarged. Okay, so this is when the object is at F. Now you bring further here, the object is in between F and P. Now if you cannot get the real image, here you can get the virtual image. Virtual means you cannot get it on the screen, you can see the image within the mirror. Here also virtual image is formed, the image is on the same side of the object and the double convex lens. In this situation it is used as a magnifying glass which is used in our daily life. Okay, next, while discussing the images, characteristics of images, we use two terms, enlarged or diminished. Enlarged means more size, diminished means size is less. So how long it is, what is the length of enlargement, what are the quantity of enlargement and what is the quantity of diminished, that is given by the magnification. So the formula to find the magnification is minus of image distance by object distance or minus V by U. Or you can use this formula also. Magnification is equal to Hi by H0. Hi means height of image, H0 is height of the object. In lenses we use the same formula, but here in mirror we are using minus V by U, but in lens we are using just V by U, image distance by object distance. That is the magnification. And another important concept is mirror formula. This is the most important thing. As you observe the characteristics, as the object is approaching to the mirror or lens, the image is moving away from the lens or mirror. That means there is a relation between the object distance and image distance. That the relation is given by mirror form as 1 by F is equal to 1 by V plus 1 by U. F is the focal length, V is the image distance, U is the object distance. The same way lens formula. 1 by F is equal to 1 by V minus 1 by U. F is the focal length, V is the image distance, U is the object distance. This is the mirror or lens formula. But only one thing you have to understand is, you should not use these formula directly. This is the most important thing. So, if F is given, V is given, you can find U. Or if F is given, U is given, you can find V. Or V is given, U is given, you can find F. Some numerical problems will be asked in the examination. While solving numerical problems, we must follow the sign convention. This is the most important thing. What we have to follow is sign convention. What is sign convention? Here, sign convention means first all distances should be measured from pole. The distances measured in the direction of light will be taken as positive. Distances measured in the direction opposite to the direction of light will be taken as negative. Height of object HO and height of image HI are positive if measured upwards from the axis and negative if measured downwards from the axis. Let us understand clearly. Here, this is the object and this is the ray passing from the object and incidenting on the mirror. So this is incident ray. Now what is the first rule? We have to measure all the distances from pole. If you measure in this direction, this is the direction opposite to the incident ray, then you have to take negative sign. If you measure in the direction of the incident ray, this is the direction of incident ray, this is the direction of measurement. In this case, we have to take the positive sign. Here also the same in the lenses also. This is the incident ray which is coming from the object and incidenting on the lens. And if you measure the distances in this direction, that is taken as negative, and if you measure the distances in this direction, they can be taken as positive. This is the most important thing. You need not worry about the sign convention. The only thing you observe one thing. What is the direction of the light passing and what is the direction of measurement? If both are same, positive. If both are opposite, negative. That is the major thing. Next. So far we discussed about the concave mirror and convex lens. But what about the convex mirror and concave lens? Here we need not discuss about all those things very clearly, because convex mirror always forms only one type of image, that is the image is always virtual, erected and diminished. In the same way concave lens also, the image is virtual, erected and diminished. Only one type of image irrespective of the object distance. So we need not worry about these two. Now, so chapter, but in this chapter, the most important thing is ray diagrams. But ray diagrams will not be given directly. Some situations will be given and you will be asked to draw the ray diagrams. Or sometimes a ray diagram will be given incompletely and you will be asked to complete the ray diagram. And here we have two experiments. One is to find the focal length of a given mirror or lens. And another experiment is to find the characteristics of images formed by the lens or mirror with various object distances. So you may be asked some questions on these experiments. And another important topic is uses of convex lenses, uses of concave lenses, in the same way uses of convex mirror and uses of concave mirrors. These are the most important topics you have to prepare in this chapter. Now, so we have completed the first and fourth chapters. Come to the second chapter. This is the very easiest chapter, chemical equations. So what are the main concepts involved in this chapter? One, chemical reaction. So how can you identify that a reaction has been taken place in between two substances? Next, chemical equations. How to write the chemical equation? Okay. Next, after writing the chemical equation, balancing a chemical equation. So what is the need of balancing a chemical equation and how to balance the chemical equation? Next, information from a balanced chemical equation. What information do you get from a balanced chemical equation? And finally, you will get some numerical problems on the balanced chemical equation. This is the very important topics discussed in this topic. And we have to focus on the balancing of chemical equation. This is the most important thing. These are all very application mode. You can practice the problems. Let us see how to balance a chemical equation. Let us see this equation. Al2O3 plus Fe gives Fe2O3 plus Al. This is called skeletal equation. Skeletal equation means it is not a balanced equation. What are the reactants? What are the reactants and what are the products? Just that gives the information. So this is to be balanced. Now what is the need of balancing? What is the need of balancing first? What is the need of balancing? Here you observe. Here we have two aluminum atoms, only one aluminum atom. Here one ferrous atom, two ferrous atoms. Three oxygen atoms, three oxygen atoms. And you studied about the law of conservation of mass in our 9th class. That is, before the reaction and after the reaction, the total mass of the system must be constant. That is the law of conservation of mass. That must be observed in this reaction. So we have to balance the chemical equations to fulfill that law. Now let us see how to balance. First, step 1. What to do? First you take the elements present in the equation. What are the elements here? Aluminium, oxygen and ferrous. These are the elements present in this reaction. And LHS. LHS means reactants. This is the arrow mark. This is the left hand side and the right hand side. The reactants are, how many atoms of reactants are there? Aluminium 2 atoms, oxygen 3 atoms, ferrous 1 atom. And on the right hand side, ferrous 2 atoms, oxygen 3 atoms, aluminium 1 atom. So this is the step 1. If you observe this, only oxygen atoms are balanced. The remaining are not balanced. Now what we do? We have to balance one by one. Now come to the step 2. So now I am trying to balance the ferrous atoms. So on the right hand side we have 2 ferrous atoms. Then what we do? I have to increase the number of ferrous atoms. For that I am introducing 2. I am increasing the number of ferrous atoms to 2. But you may have a doubt. Here it is the 2 is taken as a subscript. But why don't we take 2 as a subscript for ferrous? So we may not increase the number of atoms. We can increase the number of molecules. That is the most important thing. That's why 2 is taken as increasing the number of ferrous molecules. Okay, that's why I am taking 2. So while balancing, the numbers or digits whatever you use will not be taken as subscripts. That is the most important thing here. Now this is the while balancing ferrous, I have taken 2 ferrous atoms. Now let us see whether it is balanced or not. Now you see whether it is balanced or not. So aluminium 2 atoms, 1 atom. Oxygen 3 okay. Ferrous Here on LH side you have 2 atoms, on RH side also you have 2 atoms. Now oxygen and ferrous are balanced. Now I have to balance the aluminum. Now come to the aluminum. So aluminum on left hand side I have 2 atoms and on right hand side I have only 1 atom. Now I have to increase the number of atoms on right hand side. That's why I introduced 2 here. Now let us see whether it is balanced or not. Finally you take the table. Aluminum left hand side 2, right hand side 2. Ferrous left hand side 2, right hand side 2. And oxygen left hand side 3, right hand side 3. Totally on left hand side and right hand side totally equal. So this is the balanced equation. Al2O3 plus 2Fa gives Fa2O3 plus 2A. This is the balanced equation. Now in this chapter you will be asked some questions like what is the need of balancing a chemical equation and what is a skeleton equation, and some equations, some reactions will be given in words and you will be asked to write the equation and balance the equation, and you will be given some numerical problems on this balancing the chemical equation. So this is a very very simple chapter. If you practice them like this stepwise, then you need not worry about writing all these steps in the examination. You can directly balance the equation without writing the steps. It depends on your practice. Okay, this is about the second chapter. Now come to the third chapter. Acids, bases and salts. This is the very very easiest chapter and most enjoying chapter for you, I think, because in this chapter you have enjoyed in your laboratory. Different colors, different gases, different types of sounds, all are observed in this. Okay, acids, bases and salts. What are the basic concepts in this chapter? What is an acid and base? Testing for acid and base. Reactions of acids and bases with metals and metal organics. Strength of acids and bases. pH scale, pH in our diet, and the salts from the acids and bases. We discussed in our chapter about sodium chloride, sodium hydroxide, sodium carbonate, sodium hydrogen carbonate, bleaching powder, and plaster of Paris. These are some salts we discussed in our chapter. Now let us see. The first important thing is testing. If a solution is given to you, how to test it to know whether it is acid or base? How to test it? Now in laboratory we use 4 major indicators: methyl orange, phenolphthalein, blue litmus paper and red litmus paper. Methyl orange is the orange colored solution, phenolphthalein is a colorless solution, blue litmus and red litmus are the papers with blue color and red color. Now how to test them with acid? If methyl orange, 1 or 2 drops of methyl orange is added to an acid, immediately it turns into red color. This is the test for acid. When 1 or 2 drops of phenolphthalein is added to an acid, then there will be no change in the color. When blue litmus paper is dipped in acid, it turns into red color. When red litmus paper is dipped in acid, there will be no change in the color. Here you see red, because red is a dangerous acid. You remember that. Now coming to base. When 1 or 2 drops of methyl orange is added to base solution, then the color is yellow. It changes into yellow color. In the same way, phenolphthalein is added to base, then the color of the solution turns into pink. When blue litmus is dipped in a base solution, there will be no change in the color. In the same way, red litmus is dipped in the base solution, it turns into blue color. This is the most important thing to be remembered, and so many questions will be asked on this concept. This is the most important thing. Okay, you have to observe. You have so many acids, hydrochloric acid, sulfuric acid, nitric acid, and in our daily life we use so many acids, tamarind juice, lime juice, etc. So many acids are there. Bases also we have sodium hydroxide solution, and toothpaste, soap. These are all the bases. These are all we use in our daily life. Okay, so this is the most important test for acids and bases. Now, reactions of acids with metals. You might have found the experiment. When acid reacts with a metal, you can get a metal salt and hydrogen gas is evolved. Of course, some gas will be evolved. You cannot identify whether it is hydrogen or something. You have to test for the gas. In the same way, here you have performed an experiment. That is, you have taken HCl, hydrochloric acid test tube and added zinc. Then a gas is evolved. How you tested the gas, you know that. when a matchstick is burning matchstick is bring near the gas, you will observe a pop sound. The pop sound indicates the hydrogen gas. And reaction of acids with metal carbonates. Acid plus metal carbonate gives metal salt plus carbon dioxide gas. How to test the carbon dioxide gas? When a burning matchstick is brought near the carbon dioxide, the flame will be put off. That is the carbon dioxide. So here you have experiments on this concept, and you go through the textbook to read the experiments and practice the diagrams given for the experiment. You will be asked some questions based on these experiments. Now, reactions of bases with metals and the reaction of bases with metal carbonates. Of course, this is theoretically you can say base and metal reacts with metal salt and hydrogen gas is evolved. In the same way, base reacts with metal carbonate give metal salt plus carbon dioxide. In ordinary laboratory conditions, these are not possible. We need some advanced laboratory conditions. Of course, this is the reaction. Here also you have some experiments based on this. You go through the textbook and read the experiments. Next, pH scale, strength of the acid. So, which acid is strong acid, which acid is weak acid, or which base is strong base and which base is the weak base. Further, we have to understand about the pH scale. pH means potence of hydrogen ion, because every acid consists H plus ion. So the concentration of H plus ion gives the strength of the acid. If the concentration of H plus ion is more, the acid have more strength. If the concentration of H plus ion is less, the acid will be less strength. So the concentration of H plus ion will be measured in terms of pH scale. Now the pH scale ranges from 0 to 40. pH ranges from 0 to 40. If any solution, the pH value of any solution is 0 to 7 or less than, nearly even it is 6.9, then it is taken as the acid. If the pH of any solution is exactly 7, it is taken as a neutral solution. If the pH of any solution is taken as greater than 7, then it is considered as a base. That means 0 to 7 acid, exactly 7 neutral, more than 7, less than 14, it is a base. Now, as the pH value increases from 0 to 7, the strength of acid decreases. You see, the red color indicates more strength. Now the color is shading orange and finally it comes to green. Green indicates neutral. Now the alkaline indicates bluish color. Now the bluish color is also increasing. The intensity of color increasing. Now this finally gets the thick blue color. It is a strong base. As the pH value increases from 0 to 7, the strength of acid decreases. Whereas the pH value increases from 7 to 14, the strength of base increases. This is the most important thing to understand the pH scale. Sometimes on this concept we will be asked some questions like some pH values of solutions will be given. You may be asked which is the acid and which is the base, or sometimes you may be asked which is a strong acid, which is a strong base, like that also you will be asked pH on the pH scale. Next. What is the use of pH in our daily life? This is the most important thing. We can use pH in our digestive system. Sometimes we feel about indigestion and you will take some basic substances like antacids. And pH in soil fertility. Some soil will be tested for pH. If the soil is acidic, some bases are added to neutralize it. And if the soil is basic nature, then some acidic substances are used to neutralize it. pH in protecting aqua life. pH in tooth decay. Our mouth has a pH of 5.7. If it decreases, the tooth decay starts. To remove that, to protect the tooth decay, we use daily brushing with the toothbrush, which is a toothpaste, which is a base. pH in self-protecting of plants and animals. These are all the important topics clearly explained in textbook. Once you go through, it will be very easy. So you may be asked some questions on this topic also. pH in our daily life. Now salts. First, how the salt is formed. This is the most important thing. So generally, when an acid and base reacts together, then a salt and water is formed. That reaction is called neutralization reaction. Neutralization. So as a result of neutralization, some salts are formed, and a commonly formed salt is sodium chloride. This is formed with the reaction between sodium sodium hydroxide, a base, and hydrochloric acid, an acid. When these two are reacted, sodium chloride is formed. Of course, the sodium chloride is naturally obtained material, and this is called common salt, which we use in our daily life as a food substance. Now, from this sodium chloride, you can extract sodium hydroxide, sodium carbonate, and sodium hydrogen carbonate. Sodium hydroxide is the laboratory substance we are using in so many experiments. Sodium carbonate is known as the washing soda, and sodium hydrogen carbonate is known as the baking soda. Okay. Next, some more salts. Bleaching powder. This is the most important which we are using. The uses of bleaching powder. Here it is used as a disinfectant, and here it is used in the cloth industry or paper industry. And one of the important things of bleaching powder, calcium oxychloride, CaOCl2. And another important salt is plaster of Paris, CaSO4 half H2O. Here it is used as a decorative purpose, sealing for the houses, and it is used by the doctors to reset the fractured bones, and from decorative items it will be prepared from the plaster of Paris. These are all the very important things. Some more important uses of bleaching powder on plaster of Paris. Now, this is about the acid bases in salts. This is the most important topic, and the questions will be based on the strength of acid, strength of bases, and whether the given solution is acid or base, tests for acid and base. And sometimes you may be asked on some experiments like reaction of acids with metals, reaction of bases with metals, reaction of acids with carbonates, and reaction of bases with carbonates. And another important thing is uses of bleaching powder, plaster of Paris, washing soda, and baking soda. These are the most important topics, points you have to focus on this lesson. Most easiest lesson you can understand very well. Once you go through the textbook, you can well versed with this chapter. Now come to the next chapter. Fifth chapter. Already fourth chapter we discussed along with the first chapter. Now come to the fifth chapter, human eye and colorful world. This is the very fascinating chapter because this all deals with our eye and colors. The main topics which we discuss in this chapter are least distance of distinct vision, angle of vision, structure of eye, accommodation of eye lens, and vision defects that are myopia, hypermetropia, and presbyopia, dispersion of light, scattering of light, and applications of scattering of light. Least distance of distinct vision. What is this? This is the most important thing. For example, if we want to see an object with our eye, the distance between the eye and object is very important. The distance is called least distance, and it is taken as 25 centimeters. We cannot see the objects which are at a distance of less than 25 centimeters. Of course, it depends on the age also. That is different. And angle of vision. For example, if you go to a tree, if you want to see a tree at a far distance, you can see the top and bottom of the tree with your naked eye. If you go to that near to that tree, you cannot see the entire part of the tree. You can see some part of the tree only. That is the angle of vision. And angle of vision is taken as 60 degrees. Okay. Now come to the structure of eye. Structure of eye. So this is the eye, and of course, I am not dealing about the entire structure of eye. The what are the part we want. Actually, this is the structure of eye. You know this, and this is the eye lens, iris, cornea, pupil, and this is the iris, and this is the retina, and these are the optic nerves. These are the most important parts, and the most required parts for us are this is the eye lens. This is the most important part what we are dealing about this, and retina. So now, when we want to see an object with our eye, and the object, the image of this object will be formed through this eye lens on the retina. So retina acts as a screen. Now the signals from this retina will be carried to the brain by the optic nerve. Now this is the eye lens, and this eye lens is a double concave lens. Double convex lens. Eye lens is a double convex lens. Now here you observe one thing, one most important thing. The distance between the eye lens and the retina is fixed because generally the average diameter of eye is 2.5 centimeters. So the distance between the eye lens and retina is fixed. That is, image distance is fixed. You remember the lens lesson. image distance is fixed, but we are seeing the nearer objects and far objects. That means object distance is changing. So even though the object distance is changing, the image distance is fixed. How it happens? That is only possible with the change in the focal length of the eye lens. How the focal length of eye lens is changing? Here, this eye lens is attached to the eye with the help of some muscles. These muscles are called ciliary muscles. So with the help of the ciliary muscles, the eye lens contracts and expands. This is the most important thing. So the contraction and expansion gives the change in the focal length of the eye lens. So due to the change in the focal length of eye lens, we can see the objects. So the contraction and expansion changes the focal length of eye lens of the eye lens. This is called accommodation of the eye lens. This is the most important phenomenon what is happening in the eye. Accommodation of eye lens. So when the eye lens loses its accommodation power, then we can get vision defects. What are the vision defects? So these are actually, if you consult an eye doctor, he will discuss about so many types of vision defects, but we are discussing the vision defects only depending on the accommodation of the eye lens. Now the first defect is myopia or short-sightedness. What is this? We can see the nearer objects, but we cannot see the far objects. That is the most important thing. So these nearer objects can be seen, but the far objects cannot be seen. Why it happens? So this is the myopic eye. This is the eye of a person suffering with myopia. In this, what is happening? The image of the object is formed in front of the retina. Here the image is not found on the retina. Here the image is formed in front of the retina. So he can see the nearer objects, and this person cannot see the far objects. And to correct this myopia, we are using double concave lens. This is the diverging lens. Here the rays are joined here. We have to converge those rays, diverge those rays. So we have to use the diverging lens. That is the double concave lens. Now, what is the focal length of this double concave lens? That can be known by using the formula F is equal to minus D. Okay. So this is the myopia. Next, another important vision defect is hypermetropia or long-sightedness. What is this long-sightedness? The person suffering with long-sightedness cannot see the far objects. He can see the far objects, but he cannot see the nearer objects. The person cannot see the nearer objects, but the person can see the far objects. What is the reason for this? Here, this is the hypermetropic eye. So for this person, the image of this object is formed beyond retina. Understand? The image is formed beyond retina. So this person cannot see the nearer object. That person can see only the far objects. So to correct this hypermetropia, we have to use double convex lens. Then it will be corrected, and we can use the double convex lens to correct this hypermetropia. This is one important defect. Another important defect is presbyopia. This is the commonly observed defect in all the aged persons. This is the age-related problem. Here, the person suffering with presbyopia cannot see the nearer objects or cannot see the far objects clearly. That's why this is called presbyopia, and in Telugu we can say it as chatvaram. Chatvaram vachindantare kada. For this, we have to use bifocal lenses. That means we have to use concave lens and convex lens. Both the concave and convex lenses are used. Concave lens is used to see the nearer objects, and convex lens is used to see the far. So bifocal lenses are used for this. Is common for all people which are suffering with presbyopia, and it is the age-related problem. And these are all the vision defects about the eye. Of course, you have to take some precautions to overcome these vision defects, and you can protect your eyes. Now come to another important topic. So the lesson itself shows that human eye and colorful world. So far we discussed about the human eye. Now let us go to the another part, that is colorful world. So colorful world means we are able to see all the colors in the nature with our naked eye. How we can see the colors in the nature? That is the most important thing. To understand this, we have to understand two important phenomena of light. That is, one is dispersion of light, another one is the scattering of light. First, let us see dispersion of light. Here, a white light is passing through a prism. You might have seen in your laboratory prism, and when white light is incident on the wall of a prism, it will split into 7 colors. You can see the band of these 7 colors. This is called visible spectrum, and the 7 colors are violet, indigo, blue, green, yellow, orange, red. These are the 7 colors. Now let us see why these 7 colors are appearing. Actually, color of light indicates its frequency, and when it is passing through the prism, the wavelength changes. As the wavelength is changing, automatically the colors are split into the different colors. If you send a single color through a prism, you cannot see any different colors. Only single color will come, because color is the frequency. Frequency will not change. So these are the 7 colors, and here the wavelength of violet is very less, and red has very high wavelength. That means the wavelength increases from violet to red, and in the same way frequency decreases from red to violet. That is the most important thing. So this is the dispersion of light. So the most important natural phenomena what we observe with the help of this dispersion of light is rainbow formation. Rainbow. You observe the rainbows in your nature when the rain is coming and sunlight and rain both are simultaneously coming. And this is the entire phenomena observed in the rainbow. And this is the raindrop. When white light enters into the raindrop, it undergoes dispersion. And at one end of the raindrop, it undergoes dispersion and splits into 7 colors. And at the other end, it undergoes total internal reflection. And at this end, again, dispersion takes place. And the 7 colors we observe through our naked eye. This is the simply I am explaining, but you can observe in your textbook clear explanation about the rainbow formation, and why we are not seeing the entire 7 colors in a rainbow, and why only some major colors are appearing in rainbow. First you go through the textbook. This is the most important natural phenomena which we observe with the help of the dispersion of light. Next.
Ready.
Now another important phenomenon of light is scattering. This is the most important phenomenon. Actually, atoms or molecules which are exposed to light absorb light energy and emit some part of the light energy in different directions. This is the basic process happens in scattering of light. Actually, scattering is a very typical phenomenon, but I will try to explain it in a simple way. When sunlight falls on the atmospheric particles, these are atmospheric particles, and the sunlight has some frequency and some wavelength, and these particles also having some wavelength and frequency. Now, the wavelength of these particles, when comparable to the wavelength of the sunlight, then they can absorb, and the remaining wavelengths will be released into the atmosphere in different directions. This is the basic phenomenon of the scattering, and it has a very lengthy explanation, but this is the basic phenomenon. And what is the application of the scattering in our daily life? That is the most important. So, application of scattering of light. First, appearance of sky blue in color. Sky always appears blue in color. So, if you go to the sky, it's black in color. But when you observe from the earth, it is blue in color. This is only the scattering by nitrogen and oxygen particles in the atmosphere. And appearance of sun red in color during sunrise. And appearance of sky red in color during sunset. This is the most generally observed. Sun appears red in color during sunrise and sunset. But in the afternoon, the sun is white in color. What is the reason? During sunrise and sunset, the sun rays have to travel more distance. So while traveling more distance, they need more wavelength. And you know that red light has more wavelength. That's why the red light will be scattered and the sun appears red in color. That is the most important phenomenon during sunrise and sunset. But in the midday, the sun appears red in color, white in color. What is the reason? In that case, sun rays travel a constant distance. That's why all colors will scatter into the atmosphere, and all colors combine together to appear white in color. That is the reason. And you can you go through the textbook about these explanations, and any one of these applications will be asked in our examination. This is the most important thing. And This is about the fifth chapter. In this entire chapter, the most important topics you have to focus is, one is the defects of vision. That means you will be asked to draw the diagrams showing the myopia, hypermetropia, and sometimes you may be asked how myopia occurs and how it will be corrected, how hypermetropia will be occurred and how it will be corrected. And you have an experiment in this chapter, that is, one important experiment is there, that is to find the angle of minimum deviation of the prism and also to find the refractive index of the material of the prism. Of course, it's a very big experiment and big explanation is there, but you have to go through that experiment. And another important experiment is there in this chapter, that is formation of rainbow in your classroom. That is the one of the important experiment. And scattering, application of scattering and application of dispersion will be asked in your examination. And you have to go some minute points, that is what is the accommodation of eyelids, what is the role of ciliary muscles, and what is the role of pupil, and what is the role of iris. Like this you have to go through. This is the important topic and most interesting chapter. This is about the fifth chapter. Now come to the sixth chapter, structure of atom. Of course, some fear has occurred in your mind. Oh, such a is a very dangerous chapter. But you say physical science, whether it is physics or chemistry, any science, you have to read with logic. That is the most important. If logic is missed, the entire subject is missed. This is the most important topic. You have to read with the logic, atomic structure. The most important topics covered in this are spectrum, electromagnetic spectrum, Niels-Bohr's model of atom, Bohr-Sommerfeld model, quantum mechanical model of atom, and quantum numbers, principal quantum number, angular momentum quantum number, magnetic quantum number, spin quantum number, and electronic configuration, Auger principle, Moore's law, Pauly-Sexton principle. These are the important topics covered in this chapter. Now let us say, come to the spectrum. Coming to the spectrum, we have observed in the previous chapter, that is when white ray passes into the prism, you will observe 7 colors are formed. That is a spectrum. Spectrum means it is a group of wavelengths and group of frequencies. That is visible to our eye. That's why that is called visible spectrum with 7 colors. Now, most of the spectrum are formed with the help of electromagnetic waves. What are these electromagnetic waves? The moving electric charge creates magnetic field. So both the electric field and magnetic field both will oscillate perpendicular to each other and move forward in the medium. And their speed is equal to the speed of light, that is 3 into 10 to the power of 8 meters per second. This is the electromagnetic wave. So for any molecule or any element you take, for any element, each and every element has a definite spectrum, a definite wave and definite spectrum. This is the most important thing observed by Niels Bohr. And let us see the electromagnetic spectrum. This is the electromagnetic spectrum. Of course, as we observed in the prism, this is the visible spectrum. This is the very smallest part of the electromagnetic spectrum. This is the region of visible spectrum. And beyond this violet, you have different spectra, and beyond the red, you have different spectra. Of course, these are all ultraviolet, X-rays, gamma rays, or infrared rays, radio waves, everything. They are not visible to the eye. Only this is visible to the eye, electromagnetic spectrum. And these invisible rays also can be seen through spectroscopes. Okay. Now come to the, based on the spectrum, and Niels Bohr observed spectrum of hydrogen. Niels Bohr observed the spectrum of hydrogen. Based on the hydrogen spectrum, he gave some conclusions about the model of atom. You have studied about the model of atom in the 9th class, that is Rutherford's model of atom. And it has some shortcomings. All those shortcomings are resolved in this Bohr's model of atom. What he proposed, this is the central part is called nucleus. Nucleus consists of protons and neutrons. This is a commonly known fact. Now, electrons are revolving around the nucleus in circular paths. These paths are called orbits. These paths are called orbits. And when electron is revolving in this first orbit, its energy is constant. That's why they are called stationary orbits or shells or main energy levels, whatever it is. And Niels Bohr named them as K, L, M, N. The first orbit is K, and second orbit is L, third orbit is M, and fourth orbit is N. Taking as numbers 1, 2, 3, 4. If 1 is K, 2 is L, 3 is M, 4 is N. These are all the shells. Now, what he observed along this, he calculated the size and energy of each and every orbit, and finally he concluded that electrons are revolving around the nucleus in circular orbits. And he did a lot of work, you can see in your higher classes. But here one important defect is there in this model. Niels Bohr explained that only the spectrum of hydrogen, based on the spectrum of hydrogen. But hydrogen consists of only a single electron. But what about the atoms consisting of more than one electron? That is not explained by Bohr model. And sometimes these are all explained with the help of spectroscope. But as the days are going on, spectroscopes are highly sophisticated, and they made very sensitive electrons. Spectroscopes are made. Then, while observing, he observed some more lines in the spectrum. What are those lines? These are all some defects in the Bohr's model. Next. Now come to the Sommerfeld. He worked with along with the Bohr. That's why this is called as Bohr-Sommerfeld model. He did not give any different conclusions. Only he imagined there may be some elliptical orbits inside the circular orbit. There may be some elliptical orbits inside the circular orbits, and he named the elliptical orbits as K, but later on they are named as L. So this is called Bohr-Sommerfeld model. This is Bohr-Sommerfeld's contribution. Next, we have a lot of works in the structure, in unveiling the structure of atom, and mainly Louis D. Broglie, he said that atom has dual nature, and Erwin Schrödinger, he said he gave a concept of wave equation. While solving the wave equation, he come to a conclusion and come to a concept of orbital. What are these orbitals? Generally, we cannot find the exact location of electron, because electron is charged and highly revolving particle. We cannot find the exact location of electron. To find the exact location of electron, he imagined some path of the electron in which it is revolving, and the locus of the path of the electron can be taken as an orbital. So, to locate the electron in the orbital, he came to a conclusion of he came to a concept of quantum numbers. So, what are these quantum numbers? The first important quantum number is principal quantum number. What is this principal quantum number? Actually, in the Niels Bohr's model we studied. First shell is K, second shell is L, third shell is M, fourth shell is L. These numbers 1, 2, 3, 4 are the principal quantum number. It gives the information about the shells. If n is equal to 3, that is the M shell, like that. It is proposed by Niels Bohr. If you know the 3, that is the M shell. Already Niels Bohr calculated the size and energy of the M shell. So it gives the information about the size and energy of the orbital shell. This is the principal quantum number. Coming to the second one, angular momentum quantum number. And here the concept of orbitals comes. Here the quantum number is proposed by Sommerfeld and denoted by L. This is the information about shape and size of the orbital. So as we studied the elliptical orbits, that is the orbital. The values are taken from 0, 1, 2, 3, etc. It depends on n. The maximum value of n for a given value of n is n minus 1. So if L is equal to 0, it is considered S orbital. If L is equal to 1, it is P orbital. L is equal to 2, D orbital. L is equal to 3, F orbital. These are the fixed values. Now come to the magnetic quantum number, denoted by ML. It is proposed by Landé, and it gives the information about orientation of orbitals along the axis. What is this orientation? Every orbital consists of some more orbitals which are equal in energy to that orbital. For example, if you take S orbital, it has only a single orbital. If you come to the P orbital, it has 3 more orbitals which are equal in energy to the P orbital. They are called degenerate orbitals. If you want to identify those degenerate orbitals, and you have to use the magnetic quantum number, and the values will be minus L to plus L. It depends on L, so minus L to plus L. If L is equal to 2, then the MS magnetic quantum number values are -2, -1, 0, +1, +2 like this. So total number of values of magnetic quantum number will be 2l plus 1. That is, if l is equal to 2l plus 1 means you can get 5 values for the magnetic quantum number. They are -2, -1, 0, +1, +2 like this. Okay, this is the magnetic quantum number. So here you can observe clearly about the magnetic quantum number. First shell 1, you have only one orbit, that is one orbital, that is the l is equal to 0 denoted by s, 1s. So ml value 0, l is equal to 0, -0 to +0, 0. Second shell, in second shell you have two orbitals, 0 and 1, the numbers are 0 and 1. 0 indicates the s orbital, 1 indicates the p orbital. So 0 means ml value is 0, if l is equal to 1, -1 to +1, -1, 0, +1, like that. So you can observe the ml values here, and it gives the information about the number of subshells present in the main shell. Okay, like this. Now come to another quantum number. Now the orientation gives the degenerate orbitals. Now what are the shapes of these orbitals? Actually, every student gave an idea of orbital, that is where the electron, the region in which the finding electron, possibility of finding electron is more, is called an orbital. This is the s orbital. So this is the spherical in shape. P orbital, that is dumbbell in shape, and this is orienting along x-axis. This is known as px. Along y-axis this is py, and along z-axis this is pz. And coming to d orbital, it is double dumbbell shape. So this is dyz, dxy, dxz, dx square y square, dz square. These are the d orbitals, double dumbbell shape. This is the most important thing. Next, come to the spin quantum number. Spin quantum number is proposed by William and Goldsmith, denoted by ms. Spin quantum number means the quantum mechanical model of atom suggests that every orbital can accommodate 2 electrons only. Every orbital can accommodate 2 electrons only. So 2 electrons means these 2 electrons are having the same charge, both are negative charge. Then how they can accommodate? That means there may be a spin of electrons in the orbital, and the spin will be indicated by 2 numbers, that is +1/2 and -1/2. One is the clockwise spin, another one is the anti-clockwise spin. This is the spin quantum number. So with the help of these 4 quantum numbers, we can find the exact location of the electron. You practice by taking different values to the quantum numbers and try to find the location of electron in the orbital. This one important first. Next, come to the electronic configuration. What is the meaning of electronic configuration? An orderly arrangement of electrons in the orbitals is called electronic configuration. That electronic configuration is governed by 3 major rules: Oppo principle, Wund's rule, and Pauli's exclusion principle. And firstly, we have to understand the major rule is Oppo principle. What is this Oppo principle? So here, only very simple, electron occupies the lowest energy level first. That is the most important thing. So while filling up the electrons, first you have to fill the electrons in the lowest energy level, then go to the highest energy level. That is, if electron occupies the 1s orbital first and then goes to the 2s orbital, it continues. This is one important thing. Of course, we cannot calculate we cannot remember each and every value of energy level of each and every orbital. That's why it is modified as electron occupies the orbital whose n plus l value is less. What is the n plus l value? For example, you see, consider 3s orbital. The n plus l value of 3s orbital is n is 3. As this is s orbital, l value 0. So 3 plus 0, 3. Come to the 3p orbital. The n value is 3. As it is p orbital, the l value is 1. 3 plus 1, 4. If you compare these two, the n plus l value of 3s is 3 and 3p is 4. Which is less? Obviously, 3s is the n plus l value of 3s is less than the n plus l value of 3p. So automatically our electron enters into the 3s first, then only enters into the 3. If the n plus l values are same, this is the most important thing. What happens? See here, the n plus l value of 4p. The n value 4, as it is p orbital 1. 4 plus 1, 5. The n plus value of 3d, n value 3, d means l value 2, 3 plus 2, 5. These are same, n plus l values are same. Then how the electron will be occupied, how to decide the energy level. Here then you have to go to the n value. Here is 4 and here is 3, which is less. For 3d the n value is less, so electron first enters into the 3d, then goes to the 4p. This is the most important thing in the Abbo principle. Next. So to understand each and every energy level of orbital, this is the most important diagram to understand. First 1s is the lowest energy level, then 2s, then 2p and 3s, 3p 4s, then 3d 4p 5s, then 4d 5p 6s, like this. This is the Euler's chart, you have to understand very clearly, and if you practice the drawing of this Euler chart, you can easily identify the energy levels and you can write the electronic configuration. Very well. Now, another important rule is Moore's rule. What is this Moore's rule? Electron pairing in orbital starts only when available orbitals of the same energy are singly occupied. This is the most important. Let us explain it on an example. You take the carbon. Carbon consists of 6 electrons. How to accommodate the 6 electrons? So first lowest energy level is 1s. In 1s you can accommodate 2 electrons. So the arrow marks are different. That means one indicates the clockwise spin, another indicates the anti-clockwise spin. And next after 1s, second one is 2s. 2s can accommodate 2 electrons. 2 electrons. Totally here 2 electrons, here 2 electrons. Total 4 electrons are completed. And we have remained with 2 electrons. Total electrons are 6. So next 2p. 2p is having 3 degenerate orbitals, 2px, 2py and 2pz. So we have a common idea that we can accommodate 2 remaining electrons in the 2px. This is the wrong method according to Hund's rule. What it says, first all the orbitals must be occupied with a single electron. In case of degenerate orbitals, 1s 2 electrons, 2s 2 electrons, okay. In coming the remaining 2 electrons, one must be in the 2px, another must be in the 2py. After completion of 2pz, only the pairing takes place. That is the Hund's rule. This is what important Hund's rule. Now, while writing the electronic configuration, we have to understand number of electrons to be accommodated in each and every orbital. For example, consider s orbital at l is equal to 0. S orbital have no degenerate orbitals, so you can accommodate only 2 electrons. For p orbital, l is equal to 1, you have 3 degenerate orbitals, px, py and pz. So 3 into 2, 6 electrons can be accommodated in the p orbital. D orbital, l is equal to, it has 5 degenerate orbitals, dxy, dyz, dxz, dx square, y square and dz square, like that. These 5 orbitals, 5 into 2, 10 electrons. Coming to the f orbital, 7 degenerate orbitals, 7 into 2, 14 electrons can be accommodated in the f orbital. This is very important to understand. Now let us try to write the electronic configuration of some of the atoms. Now I have taken hydrogen, atomic number 1, symbol H, number of electrons 1. Only 1 electron, first it enters into the 1s orbital, 1s1. You can refer this Euler chart, 1s1. Helium, 2 electrons, atomic number 2, 2 electrons. So 1s2, because 1s orbital can accommodate 2 electrons, so 1s2. Boron, atomic number 5, so 5 electrons are there. Now let us see how to accommodate the 5 electrons. First energy level 1s, so you can accommodate 2 electrons in the 1s. And the second energy level 2s, so you can accommodate 2 electrons in the 2s energy level. Then after it left with only 1 electron, that can be entered into the 2p energy level, 2p1, because 2p can accommodate 6 electrons, but we have left with only 1 electron. Like that. Neon, 10, atomic number 10. So number of electrons 10. First energy level 1s, so 1s2. Second energy level 2s2, and next energy level 2p. 2 plus 2, 4. And we have remaining 6 electrons can be accommodated in the P, so 2p6. Coming to the magnesium, atomic number 12, number of electrons 12. So electronic configuration, let us see. 1s, in 1s orbital you can accommodate 2 electrons. In 2s orbital you can accommodate 2 electrons. In 2p you can accommodate 6 electrons. 2 plus 2 plus 6, 10 and you are left with now come to the, okay, come to the magnesium. Its atomic number is 12 and number of electrons 12. Now you have to accommodate 12 electrons. So the first energy level 1s, you can accommodate 2 electrons in 1s, and the second energy level is 2s, you can accommodate 2 electrons, and next energy level is 2p, you can accommodate 6 electrons. Totally 10 electrons are there, and remaining 2 electrons can be accommodated in the next energy level, that is 3s, you can accommodate 2 electrons. So 1s2, 2s2, 2p6, 3s2. That is the electronic configuration of magnesium. Like that, you can practice up to 15 elements and their atomic numbers and their electronic configuration. And now, completely in this chapter, you may be asked some questions like Bohr's postulates, what Bohr told about the model of atom, and what are the important defects in the Bohr's model. And you may be asked some questions on quantum numbers, and what is the basic for quantum mechanical model of atom. And you will be asked sometimes some quantum numbers will be given, and you have to locate the electron, exact location of electron, and you will be asked to write the electronic configuration of some of the given elements, and you may be asked some questions on Auger principle and Moore's law, like that. So this is the logical chapter. There will be links from one point to another point. This gives a lot of information. So okay students, so far we have discussed 1 to 6 chapters in the physical science, and I think you are well prepared, no doubt. Your teachers gave good directions in preparing all these chapters, but this is only a refreshing course. So whatever the inputs given in this lesson, you have to follow all these inputs, and you once go through the textbook and follow all the previous papers and questions, and then prepare well for the examination. And all the best to all of you.